Hello learners, so in this particular session we will study about general issues that are faced in divide and conquer technique. So what is a divide and conquer technique? How it is different from greedy techniques that we have previously seen, and the application of a divide and conquer algorithm that is used in binary search. So I will see that how divide and conquer technique is being employed in binary search and what is the complexity of binary search and how the algorithm for binary search works. So starting with the general divide and conquer technique, so it is different from greedy technique because greedy technique will take up the input and will add it to the solution set if it is satisfies a condition or not. But so many useful algorithms are recursive in nature. So to solve a given problem, they call themselves recursively one or more time. So these algorithms typically follow a divide and conquer approach. A divide and conquer approach method works by recursively breaking down a problem into two or more subproblems of the same time until these become simple enough uh, to be solved directly. So the solution to this subproblem are then combined to give a solution to the original problem. So what we are actually doing is that in divide and conquer approach, we'll divide the problem into smaller problems and then we'll find the solution to those smaller problems, and in the end we combine all the problems, all the smaller solution to give the final solution. So divide and conquer, as the name suggests, you have to divide a bigger problem into smaller problem and find the solution of the smaller problem. In the end you combine the solution to form a solution to the bigger problem. So it basically follows three steps. First step is the division. Second step is the sub solution or a solution of the smaller problems. That is referred to as a conquer. Second step is conquer. And the third step is your combine step. So we combine all the solution that is being there, there available with the sub solution, smaller sub solutions, and to form a bigger sub solution, to form a bigger solution to the problem. So again, three steps. First is divide, second step is conquer, third step is combine. Now, if you see what are the general issues before going into the issues in divide and conquer technique, first take a look at the recurrence relation of divide and conquer technique. So it is Tn with a followed by t followed by n by b plus the function fn. So Tn is the running time of a problem of size n. A means that in how many parts the problem is divided. N by b means the time required to solve a subproblem, each of size nb. And then in the end, there is something called dn plus cn gives you the fn, the summation. This is referred to the summation of the time required to divide the problem and combine the sub-solution. So dn will be the divide time and cn will be the conquer time, meaning the combination of the sub-problems. So if you see here, look at the recurrence relation that is being here. It just simply says that if you have a time tn, you will be required to divide the problem into n by b. So it is the time required to solve the problem, to solve a subproblem that have a size n by b, and then you are also adding the time of dividing and combining the sub-solution. So the recurrence relationship says what is the total time that you will get in divide and conquer method is the time required. First is the time required to solve the subproblems, each of size n by b, and the time of division and the time of combination of all the subproblems. So this recurrence relation represents all this. Now moving on forward, that look, we are going to discuss about what are the disadvantages or limitations or the issues that are being faced in a divide and conquer method. So the first limitation is that because it follows a recursive technique, so it will be calling the functions itself again and again. So most of the divide and conquer methods will always use the recursion. So it requires intensive memory management. So why is it so? Because a recursion is a procedure in which a function calls itself again and again. So something like if you have written AI and then inside the function you are again writing AI. So what it means is that where the parameter is I, A are again passing the parameter I to the function. So it will execute again and again and again and again until and unless there is a stopping condition. So if you forget to assign the stopping condition, it will get stuck in an infinite loop and causes a lot of memory leak problem. And if because you are using a recursion, it will again the stack is following, because recursion is based on the stack data structure, so it will open stack again and again and again. So it will be a lot of memory management that is being required there. If you're using recursion, more and more memory management have to be deployed so that you are properly managing and there is no kind of a memory leak problem exist. Another limitation or disadvantage is that the space could be overused by an explicit stack. So we've already discussed the recursion is implemented with the help of a stack data structure. So what happens is that when if there is stopping condition that is being is not met, it will again open the stack or place a calling function on the stack again and again and again. And then if you are doing it enough times, so it will consume a lot of memory. So space that is being only on the reserved for recursion, apart from it there is also another space is also required. So the space complexity becomes more in divide and conquer method. If the recursion is carried through rigorously beyond the CPU stack, the system can even crash. Again, I've mentioned that if you are not able to give any kind of a memory, any kind of a stopping condition, so the recursion will keep on going and the stack will keep on going and all the memory will be exhausted and the system can be crashed. So that is why there's a problem if you are using divide and conquer method with that. Another is overhead. So overhead is that divide and conquer algorithms can have a significant overhead because of the fact that they are using recursion and the creation of subproblem. So this can lead to increased memory usage, slower problems, slower performance as compared to other algorithms. So in other algorithms like divide and the algorithms like greedy. So greedy technique is it takes up the input, adds it to the solution set, check if it is feasible or not, then add it to the solution set. So it is as simple as that. It is not using any kind of a recursion or it's not adding anything. But in divide and conquer method, you have to subdivide the problem into smaller parts. And the solution to these smaller parts will again then be combined. So if you are seeing here, we are using a lot of resources that is being associated with the divide and conquer method. So it creates a overhead when you're using divide and conquer methods. Another is communication cost. So in some cases, the sub problems created by divide and conquer approach may need to communicate with each other. So it is definitely that if some particular sub problem is dependent upon another sub problem. So if you get an input from one sub problem, you can give that input to another sub problem and then it can be executed. So that can happen in a distributed computing environment. So again, the communication cost will be more as compared to other techniques. Another is inefficient partitioning. So because whenever you are taking a problem and you are subdividing that problem into smaller problems, it may happen that you are not able to divide the problems efficiently. If you are not able to divide the original problem into smaller problems efficiently, the divide and conquer method will lead to more problems than any kind of a solution. So the first step is that when the division occurs, you have to be very careful and you have to be take care of the fact that the division occurs in such a way that if there is any dependence on one particular sub problem to another, it has to be explicitly defined, or it has to be combined in such a way that it cannot create a overhead on the system. Another is that dependence on the size of the problem. So what do I mean by this? That the effectiveness of the divide and conquer approach can depend upon the size of the big problem that is being solved. For smaller problem, the overhead of the approach may outweigh the benefits. While for larger problem, the approach may not be feasible due to memory or communication constraint. Based on the size of the problem, if the problem is very big, so again, if the problem is big, you divide it into sub parts. Again, every part will be using recursion, so that will put a lot of constraint on the memory. So that again, that does not have much benefit so as to solve the problem directly. But if the problem is very small, where you can simply apply divide and conquer method, so that approach may not have that much benefits that by solving the problem directly. So again, it is again the dependence on the size of the problem is a very important fact that have to be considered before applying this technique. Another is limited parallelism. In some cases, it may be difficult to parallelize, meaning that if you are dividing a bigger problem into four sub problems, these four sub problems should have to be parallelly executed. So if they are able to parallelly execute it, then it is well and fine, it is good. But mostly if you are doing if some problems are difficult to parallelize, so what happens is that when you are doing a parallelism problem, so there may be some problems that can arise with the parallel processing that is being supported by the platform or not. So you have to be considerate about that fact also. So these are some of the limitations that are being occurred with the divide and conquer method. But divide and conquer method is definitely used in many popular problems like binary search, quick sort, merge sort. These are all algorithms that is being there are using divide and conquer approach. Talking about the binary search algorithm, I will be discussing. So again, binary search algorithm is a very simple algorithm. It basically works on the sorted array. So keep that in mind. If it is sorted, then binary search algorithm works flawlessly. Another thing is that this algorithm only finds the location of the element X in a linear array A. If search ends in success, it returns the index of the element, otherwise it returns -1, indicating that the X is not found. So we are talking about the algorithm, as you can see. So how this algorithm works? Firstly, there are two variables that have to be set. First is low and second is high. So set the low variable as 1, because in an array the lowest index will be 1 and the highest index will depend upon the number of elements. So if there are 14 elements, the high will be set as 14. If there are 10 elements, the high will be set as 10. Okay. So while the low is high, less than high, you have to perform these steps. First step is that while the low is less than equal to high, you have to calculate the mid by dividing low plus high divided by 2. So what this do is that if you are not able to get your desired elements in a sorted array, what you will do, you will go towards the center of the list. So this is how the mid is calculated. So if the mid is your desired element, you can simply return the mid part. If it is not, so you have to check either the returned element in mid is either less than or greater than. If it is less than, then you will go towards the left side of the list. If it is greater than, you will go towards the right side of the list. I'll show you with an example. So it will dependent upon the size, that either element is less than or higher than. So it will depend. If it is less than and higher than, it will go either left or right. So suppose in the algorithm it is given that if the x is less than equal to the mid, then you will set the high equal to mid minus 1. Or if this condition is not there, it means if x is greater than a, then the low will be set to mid plus 1. So you have to keep doing it and your x will be found. Okay. So if x is not present in the list itself, so in the end it will not return anything. So if you check here the example that is being given, so you are considering a sorted array. Keep that in mind. The binary search will work on sorted array with 13 elements. Okay, so you have to search a element. Say you want to search 40 here. Okay, so 40, calculate its 13 elements. So the lowest element will be at the index 1, highest element will be at the index 99. So the 40th element is stored at 1, 2, 3, 4, 5th index. Yeah. Okay. So how this algorithm is being implemented to calculate it? Okay. So first is the step that you will set low and high. So the lowest index that you can find is 1 and the highest index that you can find is 13. So set the low and high accordingly. So low is set to 1, high is set to 14. Then you have to calculate the mid. So mid is 1 plus 13 by 2, which will be 7. So you will go towards the 7 index element. So what is the 7 index element? Is 55. Okay. So it is 55. So the data of mid will be set to 55. Now compare the element 55 with the item you want to find. So it is 40. So check, 40 is either less than 55 or it is greater than 55. So 40 is less than 55. So what it means is that 40 is less than 55. So it means that it lies on the left side of the 55. If it is greater than a 55, it will be lying on the right hand side of the 55. So what we are doing here now, so in order to search for the left hand side, we are setting the value of high to be mid minus 1. So what is mid? Mid is 7. 7 minus 1 is set to high. So now your low is set 1 and your high is set 6. So the range becomes smaller. So the list is from 1 to 13. Now your search parameter becomes way smaller from 1 to 6. So now check. Again do the same thing. Calculate the mid. 1 plus 6 by 2, which will be 3. So the data of mid returns the element 3. At 3, 30 is being stored. Now check for another thing. Is 30 greater than 40 or less than 40? So 30 is less than 40. It means the item will lie on the right hand side. So when it lies on the right hand side, you have to change the low part. Okay. So when it lies at the left hand side, you will change the high part. When it lies at the right hand side, you have to change the low part. So now the condition where it says the else condition that was given in the algorithm is being followed. Now the low is set to mid minus 1. So your search area becomes 4 to 6. Okay, 4 to 6. So now you again calculate 4 plus 6 by 2, which returns the index 5. And at the index 5, your element that you want to calculate is being stored. So this is how your binary search algorithm works. If you can see here, it required only 3 steps. If you can see in the solution, what happens is that firstly we have highlighted 11 and 99, and after that we have finded the mid will be 55. Now we checked that mid is greater than or less than the desired element. So desired element was 40, so mid was greater than the element 40. So we know that the left part of our list contains the element. So again, in the left part of the list, we calculated the mid, which lands us at 30. And again, we compare the 30 with the desired element, which is 40. So again, what happened is that in this time 40 becomes greater than 30, so it means that the item lies on the right hand side of the list. So again, calculate the mid, you will get the result. Okay, so in only 3 steps in a sorted list, you are able to get the result by applying this particular algorithm. So rather than going one by one, if you go half by half, like you are doing the first half, then again you are dividing the list into another half. So you are getting to the solution very quickly as you are comparing it by one by one. So there is another example for the item 85. Again, if you see here, only three steps are being needed to again accomplish the same thing. So keep that in mind. If 85 is not present, so like in this example, 85 element is not present uh, in the given list. So this can also happen. So if you check here, there is no 85 element in the list. So by applying the algorithm in 3 steps, you get to know that there is no element 85. Okay, so you can also return -1 at the end if the element is not found. So if you check here, what is the time complexity of this algorithm? The time complexity of binary search is log of n, which is considered to be the best time complexity. Now, why we are calling it a log of n? Because every time when you search the list, there is a reduction of the search space by half, by a factor of 2, you can call it. Because firstly, you will calculate the whole list and you divide the list in the middle. So again, you are halving the list. Now again, in that list, you will again go towards the half mid of the element again, and you check it is greater than or less than. Based on that, again you are halving the list. Okay, so that is why the log of n complexity always will be a very good complexity, as I call it. So log of n means that if I give you an example here, that you can see the example here that uh, again in this example, if you want to find the element 7, so what you are doing here is that you started with the mid element, because if initial array is starting from 0, you can consider it. So if you compare it 7 with the middle element, which is here 6, the 7 is greater, so it means that your answer lies in the right part of the list. Now again you calculated the middle element, that becomes 10. So 10 is again less than the part. So again it is lies on the left hand side. So again you calculated so on and so forth, you will get the result. So if you calculate the number of elements, so here the number of elements are 8. So now when you calculate log 2 of 8, it becomes 3. So it means you only need 3 steps to calculate to get the result. Okay. Similarly, if you previously check, there are 13 elements. Now 13 elements, and if you take the log 2 of 13, you will get the result like this. So it will again result in 3 point something that you will get. So 3 point something. So the lower or base value of this is the floor value of 3.4 will be 3. So again you are getting the result in 3 steps. Okay, 13 element for the element 13 element for the question in which no element is being found. Okay, we are checking here it dependent upon the number of elements rather than going linearly. So if you're going linearly, what will happen? By step, if you are going, there will be a complexity of big O of n. It means you have to scroll through the number of elements that is being present. So if there are elements present, the complexity will 8. The complexity will be 8. But if you check here, the complexity reduced by 5 here, because log 2 of 8 is 3. And if you're going linearly one by one, it will take a lot of time. It will depend upon the number of elements. But if you go with the binary search, you will reduce that time to a power of 2. So always reduce that time, because you are dividing the list from half. So in this session, we have seen the introduction to divide and conquer techniques. We have seen some of the issues that are being faced in divide and conquer method. And we have also discussed the recurrence relation that is being given in divide and conquer method, the general method. And then we have also discussed about the binary search algorithm, where divide and conquer technique is applied. We've also seen the complexity, how it is being, if we compared this particular binary search with the linear search, how it is being beneficial in terms of time complexity is also being discussed in this session. So thank you.